Okay, class, this is a video that will be for Lab 9, which will be a lab about different types of reactions. So I just thought I'd start by going over the materials that you will need. Of course, you always start with your PPE for safety first, with your goggles and your gloves for eye and hand protection. And then this is the equipment that you will also need and chemicals for this lab. So just some basic beakers, graduated cylinder, a stirring rod, and also a metal spatula or spoon. And then for reagents, you'll need these reagents: copper sulfate, which is with your kit, cupric sulfate, pentahydrate, some water, and also I'm going to use for the experiment some pieces of metal. I'm going to try and use just staples, and a few paper clips and some staples for the experiment, which we'll talk about. And then another reaction, you will need vinegar and sodium carbonate. And then for the other reaction, you will need some hydrogen peroxide and yeast. So those would be the basic materials that you will need. And we're going to talk about some different reactions. The first one is going to be the combination reaction, which is just using magnesium and oxygen. That is a demonstration only, and there's a video for that in your lab. So that you will not have to use any reagents or any chemicals for that. That will be a demonstration that you will see in YouTube. So follow that video for the first one. The second reaction will be the decomposition reaction with hydrogen peroxide and yeast. The next reaction will be called a single replacement reaction, where we'll use our cupric sulfate and iron pieces of metal. And then the third reaction will be a double replacement reaction, where we will use the acetic acid and the sodium carbonate. So that's what we'll be doing and starting with. So let's get started. Okay, class, so this first reaction that you're going to do yourself after you watch the video is called a decomposition reaction, and we're just going to take some hydrogen peroxide and we're going to add yeast to it. So we need about 20 mils of hydrogen peroxide. We're going to put it in this beaker. This lab is a lot of observations, so you won't be collecting a lot of data, but you will be making observations in your lab reports. So be sure you write down everything that you observe in the experiment. So I've added 20 mils of hydrogen peroxide. Hopefully this hydrogen peroxide is still active, because it's been in the house for a while, but we'll see. So we're going to add hydrogen peroxide to the beaker, 20 mils. And then it asks you to add a small amount of yeast and make observations of what you see. So let's open up the yeast, and let's add a little bit of yeast to the hydrogen peroxide and make our observations. So this is where you can use the little spoon spatula here. We'll just add just a pinch for now and see what happens. Okay, we'll give it a little stir. And make your observations. So we see there's something definitely going on from a reaction standpoint. You can see that it's getting cloudy. Maybe see a few bubbles. I don't want to give it all away. So you will also be asked to write a balanced equation for this reaction, for the other ones as well. So take a look at the observations and come up with a balanced reaction for this chemistry. Now, this yeast in this reaction is a catalyst, so it's not a reactant or a product. By definition, a catalyst stays in the reaction and does not decompose or react. It's not a reactant or a product. So you have your hydrogen peroxide, and the yeast catalyzes hydrogen peroxide to decompose to water and oxygen. So don't worry about having a chemical formula for yeast. It's just a catalyst and will not be part of the overall balanced equation. Okay? So that's the first one. Okay, class, this next reaction is called a single replacement reaction, and we're going to take some of our cupric sulfate and we're going to dissolve some of that in water. So you take 50 mils of water. Here's our water. And we're going to add some of our cupric sulfate to that. The cupric sulfate is what you used last week as well. What I used as a demonstration for the dehydration experiment. So here's our 50 mils of water. We'll add it to our 250 ml beaker. And then we're going to take a small amount of copper sulfate. It doesn't give me an exact amount, so we don't need our balance. But let's pick some small crystals because it's going to take a while to dissolve. So I'm going to pick out some smaller crystals here that I had used last week when we did the dehydration experiment. So I'm going to have to let this dissolve for a while. So I'm going to stir that and crunch it up a little bit. So give that a minute to dissolve, and I'll be right back. Okay, class, so I've stirred this for about 10 or 15 minutes, and we see that the copper sulfate is dissolved, so we have this nice blue solution in water. And now we're going to add our metal items that they recommend. So you can use nails. There's some recommendations in the procedure to use paper clips or staples, which is what I'm going to use. But you can also use nails, needles, pins, anything that has metal that is not copper. So this is basically made of iron, is what most of these are. I'm going to add them to the copper sulfate solution, and we're going to make observations as to what happens to these items over time. So we were supposed to let this sit for at least 30 minutes, and I can see right away, you probably cannot see, but I can see right away that the surface of the paper clips is already getting dark, and so there's some kind of a reaction going on between the copper and the iron metal in the paper clips. So this is what's called a single replacement reaction, where you have the copper sulfate, the copper in the copper sulfate solution probably exchanging with the iron, so you're getting iron sulfate, and the dark material on the paper clips is actually copper metal. So it's an exchange reaction of metals with the sulfate. So we're going to let that sit and see what it looks like in about a half hour. Okay, class, this next reaction, the last one, is called double replacement, and we're going to react acetic acid with sodium carbonate. So the first step is to take and dissolve a small amount of sodium carbonate in 50 mils of water. So let's take 50 mils of water, graduated cylinder, and I found this little glass jar that I'm going to use because I'm using my 250 ml beaker is already being used for the copper reaction. So I'm going to put 50 mils in this glass container here, and then we're going to add a small amount of sodium carbonate. Dissolve some sodium carbonate. It says small amount. I'm going to take at least 1 scoop. So we'll be sure we see some kind of reaction. So let's dissolve that in 50 mils of water. It's just a little bit of small scoop. We'll see how well that dissolves. Maybe I'll add a little more water if it doesn't dissolve right away. We'll give it a stir. And we see that it is dissolving. So make your observations as you dissolve the sodium carbonate. What do you see going on in just the sodium carbonate and the water? How easy is it to dissolve? And make your observations before you add the vinegar. So I've got a little flask of vinegar here, or acetic acid. So after you made your observations on the dissolving of the sodium carbonate, I want you to add slowly the vinegar and make your observations as you add it. Okay? So let's see what happens here. Add a little bit. Okay. happens. Okay. Looks like it's fizzing a little bit. So there's something going on in terms of the reaction. Add a little bit more, another 20 mils or so. Okay, I think you can see that. So now it's definitely something going on with rapid gas evolution. So this is make your observations on this reaction, come up with a balanced equation, and then you can finish up this lab. And then we'll go back now. Let's go back now to our copper sulfate, our single exchange reaction with what's going on. So in terms of observations, you can see that the copper, we see that the copper solution is no longer blue, it's actually changing green. If you look at the color of the solution, while the paper clips are getting darker. So we'll talk about the balanced equations and the reactions for this lab in lecture as we go over the prep in class this week. But I just wanted to give you this quick video demonstration of what you'll be doing and the reagents that you'll use and the equipment that you'll need. So we'll go over the pre-lab and the procedures and what's going on with the different types of reactions in class on Tuesday, okay? So make your observations. This is another observation experiment, kind of what we did at the very beginning. So hopefully that's helpful and you'll understand the differences in the different kinds of reactions. We'll talk about that.